apply, and you can go and study 1 semester or 2 semesters without paying any extra fees. The fees you have paid for Massey University covers the fees for studying at any other university in these 25 countries here. People in the past, students in the past, went to this, applied for this exchange program, and they were successful. And you will see, if you are interested, you can go to this session, 15th of August, Wednesday break, Auckland, SNW 100, you know where it is. Now there is a session where you can find more information. What are the requirements? How does it work? What some students who went to that program think about. So it's at the bottom of your stream side. Exchange program, you can go and exchange and see what happens in some other universities if you are interested and you want to go. I think that it's available for domestic and international students, but I'm not sure. For international, I'm not sure, but you have at this web page, I think somewhere at the bottom, some student Facebook, and you can ask questions about this. Right. And we have to go back to this is your web page, stream web page, and then log out. Right. So we will briefly go over these notes covering how to write methods to initialize data members, and these are the constructors. And you will see we have a lot of constructor types, how to write the code for them, what initializer lists are, and this pointer. Be aware the best information for this constructors part is under C++ tutorial templates, but you have to read the first half. The second half is about templates. I don't know why they put them like that, but anyway. So ignore the bottom part. Read everything, examples which are there from that website. And this is a good place to clarify ideas, frequently asked questions about constructors in C++. You will see what problems other people have with constructors and what are the answers to their questions. So we have looked at a constructor, cookie cutter, blueprint, from which we can instantiate variables. So this is a new type, right? It comes with 2 data members. One is another user-defined type, point, and another is a double value. And it has 2 methods. Information hiding, data member normally are private. Tools needed by the outside world are public. Everything can work, have access to these things. Sometimes you can have variables here, but very seldom. But it's possible to have public data. Normally we have mostly functions here. This is what UML corresponding representation of our circle is. UML is a specifically designed uniform modeling language. UML is designed to create object-oriented classes interaction between them, but this is a topic of other classes. Very simple put, if you have minus in front of something, it means it's private type. If you have plus, it means it's a public type. And the order is a little bit different. The name followed by the type. And then this is a little bit skewed. The public init has 3 parameters. The public area, it's okay, it returns void. The public area returns a double, takes no argument. So the benefit of having classes defined like that is that as soon as you have them, you can use C++, you can use PHP, you can use Java to convert them. And there are even programs, not very successful as far as I know, but there are programs which take this file, UML, and convert it to a C++ program or to a Java program. So this is interesting. How to initialize data member? You have to have data members initialized because those are the differences between various objects you create of a specific type. They don't differ through their behavior. Area is the same for all objects in our circle type. But the point, the center, and the radius are different. Initialization is a very commonly done task. You can't use a variable before it is initialized. If you don't have data, how can you compute area if you don't know what the radius is? No, right? So initialization is very common, and because of this, the C++ language has decided if you don't initialize with C++ tools, the system provides you default initialization for your data. What does this mean? With our class, we have this class. We can define an object of this type. Circle inside main. C. And then we can say Cout C area. Notice I don't invoke init on this circle. There is a default method which allocates to our data, in particular in this case we are interested here, the value 0. The default values for the types, for the M center, if there is a default construction, it uses that one, and for M radius 0. And therefore, because radius is 0, this can be performed. And the output will be 0. Be aware, this works because there is a system default tool. And now we will look at that tool if we want to create it. This works fine for our circle. But when we move and have pointers to double, that default tool is not good enough because it does allocation of default values for pointer, null pointer and stuff like that, which are not good for cases when you work with data members of pointer types. Right, so what we want is something to perform initialization like this one. But if we choose a name with like init, this is something that the user has to remember. If you design your class and you say set values to initialization, the user has to again learn that method name and make the life a little bit more difficult for users of our types. Right. There is another issue. If we have classes which have constant data members or reference type members, we can't use initialization like this, because if you remember, a constant has to be initialized when it's declared. It's not possible to assign a value to MIRD inside the init and set its value. So, one, learning curve with different names here. Second, cases like constant data members or reference members, where you remember when you declare them, you have to set values. For this type of variables, an init function like that doesn't work. How can you write code here to initialize a constant data member, which was declared previously? It's not possible. So C++ introduced a mechanism of constructors which are the same, semantically speaking, in Java and PHP and Ruby and other programming languages. And I think C# has constructors as well. Now, the constructor performs initialization, but it has a specific syntax. Notice, this is a constructor for our circle class. There is no return value. This is having exactly the same name as the class itself. It can take parameters or no parameters. So it's a specific type of function. Normally, every function returns values, but not the constructors, be aware. So when we have that in declaration, what we use is what is called the default constructor, a constructor which can be invoked with no actual value. Right, so this is the constructor for our employee class. It takes two arguments, one to initialize the first data member, second argument to initialize the second data member. Please note that for efficiency reasons, whatever is passed to a method or to a function, global function, doesn't matter, when you have functions, the way to pass data to those functions is quite specific. First argument, it's native type, unsigned integer. You pass it as it is, it has using pass by value. Because what we do, we just initialize data member with whatever argument is passed here. Copy, and this is it. Whatever is of non-primitive types, user-defined types, strings, whatever other types coming from the language, string, vectors, sets, when we will talk about them, these are not primitive types. These are what we call user-defined types, or types with classes, or composite types. If you pass them by value, it's very slow. That type can have 10 data members, and when you pass it by value, each data member is copied. Slow. The way to do it is constant reference. With this constant reference passing, we achieve the same security, but efficiency. By reference, you work with something which was already defined. As soon as you put constant, it means you can't change that data. So this performs the same efficient passing as pass by value, but in a much more rapid way. You don't copy data. So be aware, this is the way to pass non-primitive types. Do not bother to pass primitive type by constant reference. This tells the reader of the code you don't know what's going on. Constant reference is the same for primitive types, has the same efficiency as pass by value for primitive types. For integers, Boolean, floats, you should pass them by value. When you don't mean to change this. If you mean to change the calling value, you pass it by reference. But 99% cases, if you put constant unsigned reference IRD, most likely you don't know the difference between the fact that the native types are passed by value as efficiently as you pass it by constant reference. So why clutter your code? Don't. Okay, now our constructor does just assigning values, as you can see, and with this, now we can invoke our, construct our variables of employee type. Very simple. Notice that we don't invoke the constructor ourselves, the system does it for us. But all you have to do is pass the corresponding number of arguments. So we construct the first object of employee type, which takes an IRD and a name, as we have seen, assigns those values, and then we can work with the variable E. When you declare pointers to our type, the beauty is that new, as opposed to malloc or calloc, knows how to work with our constructor. Of course, you have to say, construct a new employee, and this is the type you construct, and you pass arguments. Right. So, from now on, our employee type can be used very similar with the way you use integer floats and stuff like that. Right. So, this is what I mentioned before. New knows how to work with constructors, but malloc doesn't. If we put no constructor, the system provides a constructor for you. Things like this work. As soon as you have a constructor in your class, the system says you are clever enough, you know how to write constructors, from now on you have to provide everything. So be aware, as soon as you provide a constructor, the default constructor is not there any longer. What is a default constructor? A constructor which can be constructors, which can be called with no arguments. Here, notice, nothing is passed. But our class, employee, requires 2 arguments for the constructor. So this variable cannot be designed, right? So this is a problem. This was valid before, but as soon as we put a constructor in our class, the system does not automatically generate the system default constructor. As a matter of fact, if we talk about what is default generated methods for a class, be aware there are 5. Default constructor is one, we will see destructor is another one, and then assignment operator is one, member function, but we won't talk about this, member operator, and we will see copy constructor. But we are just starting talking about this. So, in order for our code to work, we have to provide a constructor like this, which takes no arguments. And then we can define variables of employee type with no arguments. So, and in general, a default constructor should emulate the way the default constructor provided by the system work. You work with default values for unsigned values, 0, I think is for integers, 0, and for the string, empty string. These are the default values. Now, with this in place, we can declare variables of employee type in 2 ways. So, rule. If you have no constructor, the system will generate something like this, which gets your data in good shape. As soon as you put a constructor like this, you have to add the default constructor. And we will see default constructor is a must for array of objects. So this also exemplifies overloading operators, overloading methods. We have 2 constructors, the same name function. No arguments here, takes 2 arguments. So we have overloaded the constructor. Now this work, we have 2 variables with different initial values set up here, right? This will invoke the one, it's the default constructor, and it's interesting. Notice that there are no round brackets. If I put round brackets here, I have a function, empt, which takes no arguments and returns the employee value. So be aware, that's why the designers of the C++ language decided to invoke default constructor like this. But in this case, we don't have invocation of a function. It's we construct a variable. It can be a little bit confusing. You can also say you have a function like emp2 takes 2 arguments and returns the employee value. But this is most unusual to have like that. So if we or someone uses an array of employees like this, remember I told you that in C++ arrays elements are initialized to default values. Global variables, static variables, they are initialized, and array elements. So, to allow for this construction of array of employees, the default constructor has to be provided, because all elements here will be initialized with a default constructor when people use that stuff. We have seen that our constructor uses assignments. And if we go back, notice here, this constructor, a string is assigned to another string. An unsigned number is assigned to another unsigned number. With this kind of construction, there are various functions called. This is an assignment operator. This is a function which is called, plus this value is stored somewhere, temporary variable, and then that is assigned to here. And this is a slow process, one reason. To speed up, okay, we have to use initializer lists. So far, we have seen, probably noticed that our employee class does not use data members that are constant or references. We have used assignments. What for constant or references data members? For that, we have to use these initializer lists. So one reason for constant and data members, which are references, we need to avoid using assignment. We can't use assignment for constant data members. Right. The constructor we have seen. One. Second, if we use assignment, it can be slow, in particular for user-defined types. If you use to assign a vector to another vector, an array of elements to another array of elements, this can be very time-consuming. So for these two reasons, and we will see when we talk about inheritance, there is another reason coming from inheritance. The best way to write constructors is with initializer lists. And those initializer lists are working like that. Our constructor, which is implemented, not inline, most constructors will be implemented not inline. So this will be the way. You have the class interface, and this is what you have in your assignment 2 part 1, given, and you have to write this in your file. It's the same file, but anyway, implementations, you have to write them, and you have to write them outside the class. In other words, non-inline. And for this employee type, we have two arguments. Notice that we have this to be a constant data member, and this is a reference data member. Because of that, you have to pass a reference data member for the second, and whatever you want for the first one, unsigned in by value. And the way to write it is after the function, a list of parameters, you put a column, and followed by the data member brackets this parameter. Apparently with C14 you will put a curly brackets here, but we will use this MIRD, so the data member is initialized from this value. The second data member is initialized from the next value. And sometimes you might have code here, or in this case we don't have anything. But if we would use integers, for example, instead of unsigned integers, we can have here if IRD is less than 0, set it to 0, because I don't accept negative IRDs. So this would be, if IRD is less than 0, IRD is 0, and then this will have only 0 or positive values. So be aware, this is the best way to write constructors. And this way of writing constructors will work for constant data members, reference data members, normal data members. And it's more efficient because with this we call the constructors of the types. And there is a lot, it's not assignment used. It's optimized by the compiler and it's much more efficient. The last topic for today. Each method of a class comes with default pointer. So assume that we have some circles like this. We have a default circle, and then we have another circle which takes 3 data, and then circle C1, C and C1, and then we call C area to be displayed, C out, C area, and C out, C1 area. How does it know, the system, that here this area has to be called for 0, 0, 0, whatever was in the circle, and how is this area has to work with C1. When we declare the C objects, each method comes with a hidden pointer C, called this. So C area, in fact, comes with this pointer, but you don't see it by default and something like that. So when we invoke the area, this points to the circle with 0, 0, 0. This pointer in C1 area points to the C1 object. So it works with this radius because it points to what data members were there. But you will see this kind of pointer is available, this. Very rarely you will use it, but there are cases in which we need it. For example, if we want to write the print function for the employee to display data on cout, we have different options. One is just to use MIRB and mName. This is a method of a class. Notice print, no arguments, it's in the class. Void, it has to have its prototype included in the class employee. And then we do it like this. You will see some people use this kind of syntax, which is a little bit more cluttered. Current object, so point this, access MIRB in the current object, access data member and name. So it's an equivalent way of writing the print function. We prefer this one. Avoid this one because it's not necessary. The only thing when I would say something like this is necessary is when you use the same MIRB as an argument and a data member. Then to distinguish between the argument passed to the function and the data member of the class, you have to use this MIRB, get the value MIRB, which is a parameter. So let the compiler know, right? If I put here print MIRB, which would be stupid, I pass an argument here, integer MIRB. This MIRB accesses the data member of the employee, and it's distinguished from MIRB eventual parameter. So be aware that each method of the class, each method we will see, which is not associated to the class itself, a method which is not static method, comes with a hidden parameter this, you can access it. But if this print would be a static method, it's not associated to any object, it's associated to a class, that print wouldn't have any this pointer. Right, constructors are called automatically when objects are created. We have looked at two constructors, default constructor, which is the one which can be invoked with no arguments, and we have looked at user-defined constructor, where we have two arguments, for example. If no constructor is defined, the system uses the default constructor. As soon as you get a constructor in our class, the system doesn't do anything for you. So we will see Wednesday, that there are more constructors, and you will hopefully work with these things when you talk about tutorial questions. So, demo for constructor, how you organize your data. once again, we have, oops, this is assignment, circle. We have the class organized like this, circle. Okay. As you can see, I split it in four files, okay. Because the circle class, this is a class listing. As you can see, it doesn't have any implementation. Constructor, default constructor, user constructor area, and then we have data members with eventually comments, which I didn't put here, because this class uses a point data member. Remember, I told you last time that this point definition has to be known to the constructor, and we have here the point class declaration. And this would be, these are the things which are given to you for your assignment. You have this with good comments in my view. You have this, oops, point class in the same file. You won't work with different files. And then we have the class implementations. So start with point class. This is the implementation of the point class. We have to include it. This will be in your stream. And this, we have all the default constructor, and I put some debugging things. I have here an evocation to the pointer name to know when the constructor is called, just to make you aware when things are performed. And then we have implementation for the getter function and for the other constructor. So we have overloading constructor here, as you can see. And we use initializer lists, right? And then we have the circle. So something like this you will have to write for each class. At the end, after the class listings, you have to write the implementation without debugging things. You don't use this, please. But here we have the circle implementation and some area and stuff like that. And then we have the test file. As you can see, we construct some circle objects. To work with that, we have to use build. I have a make file which relies on that. As you can see, everything compiled, and we got the object files created here, and after that we can run our program. And we get the areas computed for these circle objects. So this will be, I will come back to this. You don't use make file. You will see for your assignment, you use just two files. And if you use just two files, one header file and the file with main, you can compile all the time and run the program from inside main.
Wait, so for which assignment do we use two files?
Assignment 1, part 2.
Oh, because
No.
earlier you said only one file.
Oh, sorry. Now you have to write everything. Right, sorry. Now you will use one file. We are talking about assignment 2, part 1. But forget about this. You will have everything in one file for assignment 1, part 2. Everything, but you have to organize the code a little bit different. Okay, so let's stop here and then we will. So assignment 1, part 2 is one file, but you have to copy or see the headings for the class listing as I put it here. Now, this is the sample solution. Assignment 1, part 2 is out. Reading is due in 2 weeks. So have a look. And once again, this is one possible solution. You don't have to have exactly this solution, but this might be helpful. We have here 5. please pass them around. And one more. One, two. If anyone wants, they can